Bernoulli equation. Apparently, it's a super helpful equation that relates the pressure, velocity, and height of 2 points in a perfect, frictionless, incompressible flow. But what does that even mean? And why does it look like this? Let's start off by defining a fluid flow. Basically, a fluid flow is any substance, liquid or gas, air or water, that flows through or around a solid object. The Bernoulli equation is involved in a branch of physics which deals with these situations, given its own special name, fluid mechanics. To make life a bit easier, we're going to deal with flow in a pipe. Because although the equation works in a lot of other situations too, this is the easiest. We're also going to assume we live in a perfect world where there is no friction or drag. After that, there's only one thing left to check off, and that's that the flow is incompressible. All this means is that the fluid doesn't change density over the course of the flow. Just be careful not to confuse this with an incompressible fluid, because they are different. For example, air is compressible. If you have a given mass of air in a space, you can squeeze it to take up less volume, but the flow of air is usually incompressible. Naturally, a given mass of air will take up the same volume at any point in the flow. With that out of the way, on to the fluid mechanics. Starting with this little equation here. A1 V1 equals A2 V2. This is a pretty simple equation that means the cross-sectional area at a point in a pipe multiplied by the velocity at that point is equal to the area times velocity at any other point in the pipe. This means if we know any other area or any other velocity, we can work out the other variable for any given point. And it's pretty simple to do too. If we know A1 and A2, we can know straight away the ratio of their velocities. If A2 is larger than A1, we know that V2 must be smaller or slower than V1 to keep the equation equal. And it works the other way too. For example, if we know V2 is faster or bigger than V1, we know A2 must be smaller than A1 for the same reasons. Now with that handy little equation dealt with, let's move on to the big scary one, the Bernoulli equation itself. But let's not look at it directly. I think it will be easier if we came at it from a different angle, like conservation of energy. Now that's super easy, whichever way you look at it. The total energy of an object at one point must equal the total energy of that object at another point, including any sound or heat energy it has given off. So E1 equals E2, since we're in a perfect environment where such heat and sound losses are zero. And we're simply going to use fluid instead of objects. Now all we have to know is what makes up that total energy. In a fluid system, there are three parts: energy due to pressure in the fluid, kinetic energy due to the fluid's motion, and potential energy due to the height of the fluid. The equations for kinetic and potential energy on a fluid can be taken directly from what is used for an object, substituting density for mass, rho for n. Therefore, the combined energy E of a fluid is P half rho v squared and rho gz, where P is pressure, rho is density, v is velocity, g is the gravitational constant, and z is height. Now that's starting to look more like a Bernoulli equation, and combining this with the conservation of energy principle gives the actual thing, with a few subscripts to show one point on the left and another on the right. So now we know what everything in the Bernoulli equation means. How does it work? Let's say we have 2 points in a pipe, like this. To start with, we can use A1 V1 equals A2 V2 to deduce that V2 is larger than V1, and from there we can bring in the Bernoulli equation to calculate the difference in pressure between the 2 points. The height of the fluid is the same, so that means the last terms will be 0. Therefore the pressure at point 1 must be larger than point 2 to balance the equation. Easy! The equation does get slightly more complicated when the heights are different, but provided we know most of the values, we can solve to find whatever value we don't know. So to sum up, the Bernoulli equation is really just the conservation of energy principle, specifically for fluids, which helps us compare the pressure, velocity, and height of 2 points in a fluid flow, provided it's incompressible and frictionless. Let me know if this video helped you understand the Bernoulli equation, along with any other equations you need help with or want to know more about in the comments below. Don't forget to like and subscribe. Thanks for watching and keep wondering.